So hello everyone, welcome to SRBPS classes. Myself Anshul Singhal, and today's topics are that is motion. And in today's our class we will be discussing about very one important physical quantity, that is displacement. What it is, we will discuss it today. So first of all, what is motion? What is motion? We can understand it. It is a state of an object. It is a state of an object, right? Motion is just, it is a state of an object. Right? So when the state of an object is moving, then we call it object is in motion, right? When the state of an object is moving, then we can say it the object is in motion. For an instance, we can take an example, right? Suppose uh, a car is moving with a speed of 25 kilometer per hour, right? Then we can say that this particular state of this car is moving, right? Yeah, so we can say the particular car is in motion. Sometimes it may be seen that the car will not move, the car is at rest, right? So that state of an object, that state of a car is at rest. So we will say that the motion is zero. The motion is zero, right? Because the car is not moving. So before discussing displacement, we will go to our junior standards. We will go to our junior standards and discuss about three important things. That is distance, which is equal to speed into time, right? This we all have studied in our junior standards. Distance is equal to speed into time, right? So here the distance, speed and time are the three things. First of all, we will understand them. What is distance, which we already know actually. Distance is actually what it is. It is a path covered by an object, है ना? जैसे Mohan walks 3 kilometer in the morning. So we can say that Mohan's distance is 3 kilometer because Mohan has covered a path of 3 kilometer, right? So, and what about speed? Speed, we can say that speed is equal to, अगर हम इस फार्मूले से चेक करें, स्पीड अगर हमें निकालना हो तो what we will say, distance upon time. Speed will be equal to distance upon time, right? Or we can say that it is rate of path covered. It is rate of distance covered. What does that mean by rate? Means the part covered in how much period of time. जितना path cover किया है, कितने time के अंदर किया है, that is speed, right? And the third thing is time only. Time, everybody knows, time taken by an object to cover a particular area or doing any work, that is time only. So we will see what we have discussed in it. We have discussed that this distance is measured in kilometers, right? Kilometers, meters, these are its units. In this chapter majorly kilometer and meter will be useful, and it is denoted by capital D, right? Suppose if we see the sign of sum is plus, so if somebody may ask you a question that what is the sum of 2 and 3, so what you will do, you will just add, you will put a sign between 2 and between that a sign 3. So we know that the denoting sign of summation is plus, so we'll put 5. What is this equal to? This is a sign for equality, right? Similarly this distance is denoted by D. And speed is measured in kilometer per hour. Its unit is kilometer per hour, or sometimes meter per second we will use in this chapter, right? And its denoting symbol is capital S, that is capital S. And what about time? This time is equal to hours, or in some cases it is measured in seconds also in this chapter majorly. Basically we have to convert the units which you have learned in your junior classes, how to convert these units. I'm just getting a recap of it, and it is measuring quantities hours and second, and it is denoted by capital T. It is denoted by capital T. So this formula is very important, right? This formula is very important. This relationship which we have studied in our junior standard, it is very important to understand, right? So we can understand three things now. Distance is equal to speed into time. Distance is measured in kilometer or meters. Its unit is d. Its denoting symbol is d, and speed is measured in kilometer per hour or meter per second. It is denoted by capital S, and in the case of time, it is unit is hours, and it is denoted by capital T. Now we will talk about displacement. Now we will talk about displacement over here. So as we can see, displacement, what is it? Huh? First of all, we'll take an example, right? Suppose a girl is there at point A. She covers she covers 5 meters distance to reach a point C, right? From this point C, from this point C, she again covers 5 meters and reaches to point E, right? So if somebody may ask you what is distance, what is the distance covered by this girl, so what you will say? Actually she covers 10 meters, right? Because we can see 5 plus 5, 10 meters. But if somebody may ask you what is displacement, what is displacement, then what it is, right? What it is displacement? So displacement is equal to shortest distance, shortest shortest distance between initial and final position. What it is? It is the shortest distance between initial and final position. It is displacement is actually distance only, but which distance? Shortest distance between what? Initial and final position. So if we have to calculate displacement over here, so the girl's initial point was A and girl's final point is E, right? So it is the distance between them is 10 meters, right? It is distance between them 10 meters. But we don't have to calculate just distance, we have to calculate the shortest distance, right? So if she has to go back to A, if the girl is at point A, if she has to go back to point A, if she will cover this path, right? She will go from E to C, then C to A. This will be the long path. But rather than what should she do? She should she can move from here, from this E to A, diagonally she can move, right? So this will be her shortest path. How we can calculate this EA? By using Pythagoras theorem, which we have studied in our junior standards, which is equal to hypotenuse square, which is applicable in a perpendicular situation only. In a right angle triangle, hypotenuse square is equal to perpendicular square plus base square, right? Over here we can see that two sides are given, that is 5 meters and 5 meters. So the value here A is hypotenuse square, so I'm just writing AE over here, and the rest two sides is CE and AC. Let me do their squares. So that is 25 plus 25. So AE becomes root 50, right? So this root 50 is actually this root 50 is actually the displacement over here. Root 50 is the displacement over here. Its unit will be meters only. So now we can understand that displacement is the shortest path. Displacement is the short. So now let us take one more example, right, of displacement only. Suppose again a girl is there at point A on a circular track at point A. She is covering this circular path, this circular track, right? And after after every uh, its radius is 100 meters, its radius is 100 meters, right? After every after every 20 seconds she covers one round, she covers one round, right? After every 20 seconds she cover one round. So we have to calculate displacement. Then what is the displacement after 30 seconds? 30 seconds. So we can understand this question very nicely, that the girl is at point A and the radius of this circular track is 100 meters, and she is covering one circular track, she is covering one round in just 20 seconds, in 20 seconds. So after 30 seconds her position will be, see, after 30 seconds her position will be here, right, at point B, because we can understand in 30 seconds, in 30 seconds she will cover 1.5 rounds, 1.5 rounds. So when she completes her one round, she will again reach to her original position, and after covering half more round, she will be at this position, right? So if somebody is asking, if in this question it is asking what is displacement, what is displacement? So what do we tell? Displacement, as we already know, it is the shortest path between the initial and final position. So its initial position was A and the final position is B, right? Initial position is A, final position is B. If she goes from this path, right, this is a long path, but if we see, if she directly goes through diameter, right, if she directly goes through diameter, then this is the shortest path. So diameter will be equal to twice of radius, है ना? Diameter is equal to twice of radius, and radius we know that it is 100 meters. So diameter will be 200 meters, and the diameter is only equal to the displacement. It's 200 meters. Okay. One more example I'll take from here. Suppose a person at point A goes to point B and then goes to point C and then goes to point D and again goes back to the point A, again goes back to the point A. He's going from A to B, B to C, C to D and D to A, and his original position, the final position, is again A only. So what is the displacement? What is the displacement? So what we can say, as initial and final positions are same, final positions are same, so displacement will be 0, displacement will be 0. But if somebody may ask you what is distance, what is distance, so what you will tell? If the distance from here is 5 meters, 5 meters, 5 meters and 5 meters, so the distance will be equal to 20 meters, right? So distance is equal to 20 meters, but displacement will be 0 only. So what we can say, the displacement could be 0 also, but displacement could be 0 also, but distance could never be 0. All right. So today's session is about displacement only, and in next session we will continue.